So till the last session, we have completed the design part of design analysis and modeling of isolated square footing. So in this session, in the next 2 to 3 sessions, we'll be focusing on how to design and design model and analysis of isolated rectangular footing. So that's what we are going to focus from this particular session to the next 2 to 3 sessions. So design of rectangular footings, isolated rectangular footings. That's what we are going to see. So we have already completed the manual design part. So I'll just show you quickly what actually we have done in the manual design. So let me show you that. So here you can see there is the mixed design procedure. I mean, not mixed design, the rectangular footing design procedure. So you can see the problem statement here. That a solid footing has to transfer a dead load of 1200 kilonewtons and an imposed load of 300 kilonewtons. So these are the loads that are acting on the footing. So, and you can see the column size, which is basically a rectangular column. So we have already discussed about one blind thumb rule. That is, if it is a square column, we always prefer to design the square footing. If it is a rectangular column, we always prefer to design the rectangular footing. But this is not necessary in all the cases. But 90% of the times we'll go with this kind of thumb rule only. Okay, right. And then you can see the materials M20 grade of concrete and Fe415 grade of steel. And the SBC of soil is 300 kilonewtons per square meter. And the allowable settlement is 25 mm. So with this problem statement, we have completed the design process. First, we have ensured the dimensions, that is in-plan dimensions, which are basically the length and width of the footing. And then we have talked about the area of the footing. And then we have discussed about the upward soil pressure, depth of the footing, one-way shear, two-way shear, all these things we have completed, right? So the same thing that we are going to do in the CFSI SAFE software by doing the modeling and analysis part, right? That's what we are going to do now, right? So now let me go to the CSI SAFE software. You can see all the final details also you can see, right? So with the same problem statement, we are going to look after the CSI SAFE software. So in the CSI SAFE software, so just open the software and then let me create a new model. So how will you create a new model? Just go to File and then click on New Model. That's it. So you can see the new model has come, right? So now here we have to decide a couple of things. What are they? The first one is the design code. So the design code which we follow is IS 456-2000. So select the code that we follow accordingly. So IS 456-2000. And then the design preferences, we don't need to do these design preferences. Even if you want to change also, you can change here itself. But in the later cases also, we can change. But anyways, so let us give the minimum cover to the slabs. So for footings, we will give the cover as 50 mm. Okay, that's what we give. But before that, here the values are in inches. So let me convert those inches first. So I'll change the metric defaults. So make sure of units to be in metric defaults. Currently, you can see it is in US. Okay, let me click on modify or show and then click on metric defaults. Click OK. Right. So now you can change the design preferences. So just click on modify or show minimum cover to the slabs. So we have already talked for footings, we'll give the bottom cover and top cover as same values, which is 50 mm. Okay. And the bar size that we usually prefer is 16 mm diameter bar. So for 16 mm diameter bar, directly we don't give the bar size as 16 mm because while calculating the effective depth, it will not consider the full size of the bar. What it will do, it will consider the half of the size of the diameter of bar. So here, instead of 16, you directly give it as half of the 16, which is 8 mm. So let me give that value as 8 mm, right? So these are the brief details that we can give. Remaining things, we can change it in the later cases also. So click OK. And then now we need to go for the blank. We don't need any kind of grids. So let us do the modeling part in the blank area only. So let me click on blank. So that's the first step. So what is the first step that we have done? We have initialized the model. So I'll write the steps also. So the same steps, but I'll make it in a different way. So first step is initializing the model. Initializing the model. Right. Now the second step. The second step is once we have initialized the model, what is the next step? The next step is we have to define the properties. What properties? We have to define material properties. Okay, define material properties. So let us define the material properties. So what are the materials that we have? We have two types of materials. One is concrete and the other one is steel. So concrete is basically M20 grade of concrete and steel is basically Fe415 grade of steel. So let us define these two things. So how will we define? So just go to define materials and then here we are going to add our materials. So just click on add new material and then give the material name. So I'll give the material name as M20. Okay. And then material type. So it's basically a concrete. So let me select concrete and then weight per unit volume. What is the unit weight of RCC? It is 25 kilonewtons per cubic meter. And the Young's modulus of steel. So how will we calculate Young's modulus of steel? 5,000 times of root FCK. That's the formula. Okay. 5,000 into root FCK, where FCK is grade of concrete. Okay. So that's how we can define this value, right? So let me give the modulus of elasticity of concrete, which will be 5,000 into, okay, 5,000 multiplied by square root is QRT. Software itself will calculate. You don't need to bother that, but you just have to enter the values in a proper value, proper format. Okay. So 5,000 square root FCK and then click enter. Now you can see the Young's modulus of concrete or modulus of elasticity of concrete. Right, 22360.679. Poisson's ratio, let it be the same. And then coefficient of thermal expansion also let it be the same. And then concrete cube strength. What is the grade of concrete that we are looking for? M20. So just type 20 there. Right. And then we can go for OK. So click OK. Right. So we have added M20 grade of concrete. Now we have the second material, which is called as Fe415. That's grade of steel. So just click on add new material, give the material name as Fe415, and then the material type is basically rebar. So you can use steel or rebar, anything is fine, but preferably we'll go for rebar only, not for steel, because when you give steel, it will consider as the steel section. So we basically design the rebar, okay, reinforcement bar, right? And then the unit weight of steel, which is 78.5 kilonewtons per cubic meter, and then modulus of elasticity of steel is 2 times of 2 into 10 power 5. Okay, so 1, 2, 3, 4, 5, right? And then yield stress and the tensile stress, it is same as the grade of steel, which is 415. So just give the values as 415 in minimum yield stress, and in minimum tensile stress also the value remains same, which is 415. So and then click OK. So with this, we have added the two materials. You can see M20 and Fe415, right? So just click OK, right? So with this, the second step is completed, which is defining the material properties. Now the third step is define which properties. So we have to define the section properties now. So that's the third thing. So what does it mean by section properties? Section properties is nothing but we have to design the, or we have to define the thickness of the slab. So that's what basically the section property. So here, what we will do is first let us see in the manual design process, what is the overall depth of the section or overall thickness of the slab. So what's the thickness of the slab that we have considered? Let me check that. So just give me a second. Yeah, here you can see. So the overall depth we have considered it as 650 mm. So let us design with 650 mm. Right. So just go to define, because here also we need to define the section property. Section is nothing but slab here, that is foundation slab. So just click on define and then slab properties. So click on slab properties and we need to add the property. So just click on add new property and we have to give the naming to the property. So I'll just give it as FT. Okay, that is footing. What is the overall depth of the footing? 650 mm. And what is the grade of concrete? M20. So I'll just give it in this way. You don't need to follow the same process here, but you can give any name, but make sure you follow a proper format so that you don't forget in the later cases, right? And what is the material of the slab? It's basically concrete. So let us give M20 grade of concrete. And then the type. So here we are going to design the type, which is footing. So we are going to design the footing. So select the footing here, okay? And then thickness. So here the thickness value is, what is the thickness of the footing? It is 650 mm. So just give 650, right? and then click on OK. Right. So that's the material slab property. Now, I told you that in the previous sessions also, if you remember, so there will be one part in the foundation slab which is called as a stiff portion. Okay, there will be one portion which is called a stiff portion. What is stiff portion? Whatever the depth of the foundation that is there, or whatever the foundation depth is there, just underneath, exactly under the column, that's called as stiff area. So this is the portion which we call it as stiff area. So if you remember, for the design of isolated square footings, I have designed both the stiff area and the normal one individually. Now what we will do is we will do together. Okay, the stiff area I will define the slab property now itself, and the original property also I'll define now itself. Okay, so we need to define both. So don't think that only one is required. So first let us define the original one, and then we will define the stiff portion. So the next thing is we will define the stiff area, right? So let us define the stiff area. So how will you define? So again, we need to add new property and then a dialog box. So here we'll give the name as stiff area, and material is again the grade of concrete, which is M20. And here, what is the type that we are defining? We are not defining the footing. What we are defining? We are defining the stiff area. So just click on the drop down and select stiff, right? And then here, the thickness value. When you are giving stiff area, you don't need to give any value here. Okay, there is no rule that you should give only 600 or whatever is the depth of the footing. You can give any value for the stiff portion only. Remember that for stiff portion, when you select footing here, okay, when you select footing here, you should give the depth of the footing. But when you select the stiff portion, you don't need to give any value here. You can give some random value. That doesn't matter, and that doesn't impact the design process also. Okay, let me give the 200 only, the default value. Or if you want, you can change that value also. Let me change 300 also, no problem. Right, and then click on OK. So we have defined the material properties, sorry, section properties. So section properties are, one is the footing one and the other one is the stiff portion. These two are the section properties, which are basically the slab properties, right? So click on OK. So we have defined the section properties. One is the footing property and the other one is stiff portion. Both we have completed, right? And then the next property or the next step is we have to define the soil subgrade properties. Okay, define soil subgrade properties. That's our next step. So what is meant by soil subgrade properties? That is subgrade modulus. So how will you calculate the subgrade modulus? So subgrade modulus is defined with K. Okay, if you remember, the subgrade modulus is defined with K, right? So now what we will do is we will define the subgrade modulus. So how to find out the subgrade modulus? So we have already calculated this one. So subgrade modulus, how will you find out is, let me get the SBC of the footing. So let me check what is the SBC of the footing. SBC of soil basically. So it is 300. So total SBC upon, okay, K equals to SBC of the soil, that is 300 divided by the footing settlement or the allowable settlement in the footing. So which is 25 mm. So I'll convert that into meters. That will be 0.025 meters. So if you solve this value, it will be 12,000 kilonewtons per cubic meter. That's the value of K. So we have to define this K value now, which is called a soil subgrade property. So let us define that. So how will you define the soil subgrade property? So just go to define, and then here you can see soil subgrade properties. Click on that, and here we have to define that. Okay, either you click on add new property or you can modify the existing one also. Anything is okay. Let me modify the existing one. So modify or show property. Let me click on that. So here the property name. So what will be the property name? So I'll give it as SBC 300 at the rate 25 mm. 25 is nothing but settlement and 300 is nothing but the SBC of soil. So I'll give it in this way. And then the subgrade modulus. So what is a subgrade modulus? So we have to solve this one. So how will you solve? Subgrade modulus is nothing but K. So how will you define the value of K? So it is basically defined as the ratio of the SBC of soil upon or divided by the settlement, allowable settlement, that is 0.025. So if you click enter, it will automatically calculate, which is 12,000. So here also you can see it is the same value, right? So, and then we are going to define it for compression only, not for any other, just compression only. And then click OK, right? So we have defined the soil subgrade property also, right? So with this, the properties are completed. Now, what is the next step? The next step is we need to draw the footing. Okay, let us draw the footing now. So the next one is draw footing. So how will you draw the footing? So we have this option which is called as quick draw areas around point. Okay, this one. Okay, quick draw areas around a point. So let me select that one. So just click on this one. You can see the cursor. I'll keep the cursor there. Quick draw areas around points. So click on that, and then a dialog box pops out. And here we need to select the specifications. So what is the type that we are designing? We are designing the slab. Okay, type of object is slab. Okay, and then shape of the object is basically rectangle. So we don't design circular ones. So we'll give it as rectangular. And then the property. So make sure to select the right property, which is FT650-M20, not the stiff. We are not designing the stiff now. So we'll design first this one. And then once we defined this one, then we'll go for the stiff portion, right? So footing, and then the dimensions. What is the dimension of the footing that we have decided in the manual process? So let me check that. You can see the length of the footing is 2.5 meters and width of the footing is 2.25 meters. So the value of x will become 2.5 meters and the value of y will become 2.25 meters. So let me write the same value. So x dimension is 2.5 meters and y dimension is 2.25 meters. And trimmed slab edges, let it be S, right? So now once you have selected all the specifications, just click anywhere on the cursor, anywhere in the window. So let me click here so that you will see the footing. So let me click there, right? Now can you see the footing? Right. So this is our footing. So now let us model the stiff area also. Okay, along with footing, let us model the stiff area. So now let's model stiff area for the column inside the footing. Okay, whatever this is the footing. So inside this footing, we'll model the column. The stiff area for the column. Right? How will you model the stiff area for the column? Again, so let me close this dialog box or discontinue this. Now click on this one again, quick draw areas around points, click on that. And then here we need to select the type of object. Now, the type of object that we are going to look after is slab, okay? And then shape is rectangular and property. So what is the property here? It is not the footing, it is the stiff area. So let me click on stiff now and then give the dimensions of what is the dimensions that we have to give. Here, the X and Y dimensions are basically the dimensions of column. Remember that. Okay, the dimensions of the column. Why we are giving the dimensions of the column? Because we are giving the stiff area. What is stiff area? Whatever the portion that is there exactly under the column. Okay, exactly under the column. So that's why we are giving the dimensions of column, not the dimensions of the footing. But when you select the property as a footing, then we have to give the dimensions of the footing. That's why in the previous case, we have given the dimensions of the footing. But now we have to give the dimensions of the column since we have selected the stiff area or we are modeling the stiff area, right? So let me select that. So let us see what is the dimension of the column. So you can see 230 by 450 mm. Okay, 230 by 450 mm. So here the smaller dimension will become y and the bigger dimension will become x. Remember that. Okay, the smaller dimension will become y and the bigger dimension will become x. So let me define those values. So the smaller dimension is basically y. So which is 230 mm, that is 0.23, and the bigger dimension is x, which is 450 mm. That's the dimensions of the footings, 230 by 450 mm. Right. Once you see, select these ones, then just move the cursor to the center point. You should see that midpoint. Okay, till you don't see the midpoint, you have to move the cursor. And then once you locate the midpoint, then click. Okay, once you locate the midpoint in the footing, just click and you will see the rectangular column has been modeled. Right. Can you see the rectangular column? That's basically the stiff area has been modeled. Right. So let us disable the command. Right. Suppose if you don't want to see the grids, so how will you check that option. So we have this option which is called as set display options. And here you can see option called horizon. So just uncheck this one and then click OK. All the grids will get disabled. Okay, right. So now the next thing. So what we have done so far, we have drawn the footing. Now the next thing is we have to assign the loads. Okay, assign the loads. So how to assign the loads? So in order to assign the loads, just go to draw. Okay, first we have to select a point where we have to assign the load. We have to assign the load exactly on the column. Okay, we have to assign the load exactly on the column. But how will you assign the load in the column? So first we have to define the center point or midpoint of the column. And then on that midpoint, we have to assign the load. Right. So if you go to 3D view also, you can see this one. Okay, this is the stiff area. Right. So now let us assign the load inside the center of the column. Okay, inside the center of the column, we have to assign the load. Remember, the bigger square, this one is actually the footing, and this is actually the column. Remember that column or stiff area, right? So now let us assign the loads. So before assigning the loads, let us draw a point in order to assign the load exactly on that point. So just go to draw and then go to draw points. Okay, and then here the point offset, nothing we not need to select. Just click on the midpoint by moving your cursor to the center of the rectangular footing, rectangular column. Right. So let me click here. Right, that's done. So we have defined the midpoint. So let me disable the command by clicking on select object. Now let us assign the load. So how will you assign the load? So first we have to select the point. So whichever point we have to assign the load, first we have to select that point. So just keep an eye in the bottom left side of the screen. Currently nothing is selected. You can see here. Now once I select this particular point, here you can see one point selected. Okay, let me show you that. So let me select that point. So how will you select a point? Either you can click on that point. Okay, but make sure here it is selecting 4 edges. So that should not be the case. So drag it from left to right so that that midpoint will get covered. Right. So now you can see one point selected. Can you see at the bottom left side, one point selected? Right. So on this point, we are going to assign the load. Right. So how will you assign the load? Just go to assign. Right. So just go to assign and then what type of load it is? It's a point load. Go load data and then point loads. So just click on point loads and we are going to give the live load, not the dead load. So select live and then let us see what is the total load intensity. So let me go here and let me check the total load. So you can see the total load is 1500 kilonewtons. That's what it is coming down. So let me give 1500 kilonewtons. Right. And then the moments, nothing we don't need to give. And here the size of load for punching shear. That means the dimension of the column. So I told you, so the smaller dimension will become Y and the bigger dimension will become X. So here we should give the dimension of the footing. So what's the dimension of the footing? 230 by 450 mm, you can see. So the smaller dimension is Y. So that is 230 mm and the bigger dimension is X. Remember that it's always same. That is 450 mm. And then you can check on replace existing loads or add to existing loads. Currently, we don't have any loads. So even if you give this point, that doesn't make any difference. Let me click on replace existing loads. By any chance, if there are any loads I have assigned, it will replace them. Right. Let me click on OK. Right. So with this, you can see the load has been assigned. Now, if you want to clearly see the load assignment pattern, just click on 3D. Right. Can you see? The 1500 kilonewtons of load has been applied. Right. So now what we will do is we are going to assign the soil property. Okay, we will assign the soil property. So what does it mean by soil property? The subgrade modulus. Okay, basically the value of SBC of soil. Right. So let us assign the soil property. So that's our next step, you can say, or sub steps. Let me keep it as sub steps only. Assign loads and then assign soil property. Soil property. Okay, right. So let us assign the soil property. So how will you assign the soil property? In order to assign the soil property, select the footing. So we are going to assign the soil property for footing, not for the column. Why? The reason is whatever the footing that we are going to design, this footing will be resting on the soil. It is not the column that is resting on the soil. column will be resting on the footing. Okay, column will be resting on the footing. So that's why we don't apply the soil property for the column. We apply the soil property only for the footing, right? So let us assign the soil property for footing. So just select the footing. So make sure you have selected the footing, and you can see at the bottom left side, one area and 4 edges selected. So one area is this total footing, and 4 edges are these ones. 4 edges of the footing, right? So now let us assign the soil property for the footing. So how will you assign? Just go to assign. In the assign, you can see support data. In the support data, soil properties. So just click on soil properties, select the one that we have given, and then click OK. Right. So you can see the green color plus mark symbols that you see. So which indicates you have applied the soil subgrade, soil property. And you can see SBC of SBC 300 at the rate 25. Right. So now to design the foundation, we have to draw the, or we have to design stiff area. Okay, we have to draw the stiff area. But unless and until the area of the footing, the depth of the footing is not satisfied, don't try to draw the stiff area. Okay, we don't know what is the stiff area and all. So we should not draw the stiff area now. So once we finalize the area of the footing and depth of the footing, then only we'll go for the drawing of the stiff area or design modeling of the stiff area. So that is punching shear area, that is punching shear should be safe. Punching shear is nothing but two-way shear. So once punching shear is safe, then only we'll go for the stiff portion design. Okay, so punching shear area should be safe, upward soil pressure should be safe, and settlement also have to be safe. Only when all these three conditions are getting satisfied, then only we will draw the stiff area. Remember that. So punching shear, that's basically two-way shear. So first this has to get satisfied, and then the upward soil pressure. Okay, the soil pressure has to get satisfied, and the last one is settlement also should be within the limits only. Okay, settlement also should be within the limit. Once all these three conditions are getting satisfied, then only we will design the stiff portion. Till then, we should not look after the stiff portion modeling. Right. So first let us check these things, and then we'll go for this one. If they are within the limits, let us check that. Right. So now the next thing is we have to define the load combinations also. Okay. So not just a single loads, we always have the combination of loads. So assign load combinations or define load combinations as well. Right. So how will you define the load combinations? So just go to define and then load combinations. Let me check that where it is. Yes, load combinations. Click on that. And here we need to add a new load combination. Just click on add new combo and then combination 1. Basically, the load combination name is dead load plus live load. If you have more combinations, you have to add all those combinations. Right. And then click on the combination type. So the combination type here is, it's basically the linearly add. So nothing much you can change here. And then here we have to give the load names. So first one load is dead load, and then the second load is live load. Select both, and the factor of safety for normal condition is 1. So just give 1 for dead load and live load. Okay, right. So and then click here the service normal. So make sure to select service normal. We are assigning the normal loads, not the factored loads. Once we assign the normal loads, then we can assign the, or we can add the factored load combination as well. So just click on OK. Right, we have assigned the normal load combinations or service load combination. So now let us assign the factored load combination. So again, click on add new combo. Okay, and here the combination name I'll give it as 1.5 dead load plus 1.5 live load. Right, and the combination type is linearly add, and then here in the drop down. Okay, so select the dead load. Okay, don't select the combination, select dead load, and then here live, and the factor of safety is 1.5. Make sure of that. Okay, so and here it's basically an ultimate load combination. That means it's a strength ultimate. For service load combination, it is service normal. For factored load combination, it is strength ultimate. Right. So check strength ultimate and then click OK. And we have assigned both the load combinations. Right. So with this, every part is completed. The modeling part is completed. So once after completing the modeling, the seventh step is we need to check for the analysis part. So run analysis. Run analysis. That's our next part. So how will you run the analysis? So here we have this option, run analysis and design. So click on that. So let me click on that. If you have not saved the model, it will ask you to save the model. Only after successfully saving the model, then only the analysis will run. Let me show you that. So currently I have not saved the model. So let me click on run analysis and design. And you can see it is asking me to save the file. So let me save the file somewhere. Let me give me a second. Right. So let me save here. I'll just give it as name as model 2. Model 2. Right. So here I'm going to select that. So I'll just give the name as isolated rectangular footing. Right. So you can see the analysis is preparing to run an analysis. Once the analysis is done, okay, you can see the analysis is completed. Right. You can zoom in and then now what are the things that we need to check once after completing the analysis? We need to check 3 things. What are they? So let me give it as 7.1. So check upward soil pressure. That's the first thing that we have to look for. Upward soil pressure. Okay. So once after we check the upward soil pressure, we need to look for the settlement and then punching shear. Okay. So let me give it here. So once after the analysis is done, I'll just keep it in this way. Check upward soil pressure, check settlement. That's the next step. Next thing that we have to look for. After settlement check, then we have to look for the punching shear. Okay, check punching shear. Right. So let us look one by one. So first upward soil pressure. So how will you look for the upward soil pressure? So we have this icon which is used to do the which is used to check for the upward soil pressure. So you can see I will keep the cursor show reaction photos. This is for upward soil pressure checking. So click on that and then the load case is basically, so when you are going for upward soil pressure, the load combination we have to select, which is dead load plus live load. And then we are going to look for soil pressure, display contours, and these things let it be the default, and then click apply and close it. So once you see here, the upward soil pressure at the center of the footing, you can keep the cursor there and you can see the value as minus 286.65. Okay, the minus 286.65. So here, the upward soil pressure, I told you how to check with the upward soil pressure. So you can look for the manual calculation also. So let me, yeah, you can see it is 293.33. Okay, it is 293.33. So you can see the here it is 286.65. That's almost close. So that's not a problem. Okay, that's not a problem here. But anyways, I have already told you how to work with the software combination. Why how the software will calculate? So if you look here, I have given the dimensions here. Let me see the upward soil pressure. It is 293.33. Okay, in Excel sheet it is 293.33, but in CSI CF software it is 286.65. So what is that? Why this difference? The difference is because in manual calculation, when we are calculating the self weight of the footing, how we have calculated the self weight of the footing is taken as 10% of the load coming from the column. Okay, 10% of the load coming from the column. But in actual case, it will not be that way. Why? Because if you look at the Excel sheet, let me show you that. Right. So here you can see in the Excel sheet, what is the weight percent of loading? It is 5.63. That means safe software is considering only 5.63 percentage. So that's why that difference, but that doesn't bother much value. So that's not a problem. So don't bother about that. They're almost close. Okay, 286.65 and 293. That's the upward soil pressure, right? 293. So which is almost close. So no problem. Right. So once after we have checked the upward soil pressure, the next thing is settlements. So how will you look for the settlements? So in order to look for the settlement, we have this option, which is this one. Okay. So let me click on this one. But remember, settlements also have to be checked for service load combinations. Okay, so let me click on this one, show deformed shape. Okay, click on this and the load combination, which is dead load plus live load, and then click apply, close. Right. So if you move the cursor, you can see what is the settlement value. You can see the value minus 23.88. What is the allowable settlement? The allowable settlement is 25 mm. So the allowable is 25 mm. So maximum it is 25 mm. And how much we are getting? It is 23. So which is within the limits only. So no, there is no problem. Okay. And remember that the upward soil pressure has to be in negative only. I told you that in the previous classes also. Please remember that. So when you get positive, so when you have the negative upward soil pressure, that means settlement will happen. If you have positive upward soil pressure, then uplifting will happen. Right. So now the last thing is we have to look for the punching shear. So how to look for the punching shear? So here we have this option which is called as check punching shear design. Let me show you that. This one. Okay, punching shear design. Let me check that. So click on this one, show punching shear design. Okay, click on show punching shear design, and you can see the punching shear value, which is 0.704. How to know whether this value is within the limits or not? When the punching shear value is less than 1, then it means it's a safe. Okay, if it is less than 1, then it is safe. But I told you we have to check for one more thing, which is we have to check for two things. One is whether the safe software is considering IS code or not. That's the first thing that we have to look for. And the second thing is the location of the column. Okay, the location of the column. So where the column should be there in the footing, it should be there in the center. Okay, it should not be there in the edges or in the corners. So we have to look for these things. So just because here you got less than 1, that doesn't mean these two conditions are also getting satisfied. Even though if you are getting less than 1, okay, you have to check for these two cases. Make sure of that one. Right. So now how to check for these two cases? So just keep the cursor at the center. Okay, keep the cursor at the center and then right click. Okay, keep the cursor at center and then right click. Right. So now you can see the first condition. What is the first condition? Whether it is considering IS code or not. Yes, it is considering IS code. You can see here. Okay, it is considering IS code, IS 456-2000. So this is correct. So this is no problem. Now the next one is location. So let us check the location. So where the column is locating, you can see here. So it is basically at the edge. So where it should be there, it should be at the center. So whenever we design a footing and whenever we design a column inside that, we always try to place the column exactly in the center of the footing. So here what it is considering edge. So this condition is not getting satisfied. So what we have to do, we have to change the column location to center or interior, you can say. How to change that? Let me show you. So for that, before that, let me close these ones. Let me close this dialog box also. Right. So now let us do the punching overrides. Right. Why? Because the column is in the edge. So we have to change the location of the column. So how to change? So first select the point that you want to change, because the column only we have to change. So we have to select that point. So select the point by dragging. Okay, select the point by dragging. Right, you can see one point selected. Right. So once this is done, the next thing that we have to do is just go to design, and here you will see punching check overrides. So select this one, and then here we have to change the location type. You can see the location type. So it is automatically considering, so we have to change it to interior. So select interior and then click OK and then click yes. Right, that's that. Now, once again, we have to perform the analysis. Why? Because we made some changes. Whenever you do some changes, you have to do the analysis part. So let me click on analysis. Right, analysis is also completed. Now let us check the punching shear. So how will you check? You can click on this option, show punching shear design. Right, now can you see? It is 0.6858. Okay, it is 0.6858. Right, now let us check again, once again, whether it is taking for the IS 456 code or not. So let me keep the cursor at the center and then check here. Right, IS 456, this is getting satisfied. And then the column location is interior. And what is the next thing that we have to look for? The punching shear. I mean, effective area for punching perimeter. This you don't need to check much, but it will be fine, almost fine. There won't be any problem, right? So, and then what else that we have to look for? Yeah, nothing much. Yeah, these three things that is fine, that are fine as a beginner, right? And then click close the dialog box, right? So now what we have to do, we have completed the analysis part. So what we have understood from the analysis part, everything is perfectly fine. All these three conditions are satisfying the limits. Now the next thing is we have to go for the design process. Okay, we have to go for the design process. I told you, once after these three things are satisfied, then only we have to look for the design of stiff portion. Okay, design of stiff portion. Now let's do that. That's the stiff portion design. So how will you do that? So for that, so for design, we have to draw the design strip. So in order to draw the design strip, first we need to unlock the model. So just click on unlock the model. You can see on the top quick access bar, unlock the model and then click OK. Right, all your analysis results will be gone. So now let us do the design strip or the stiff area design, you can say. So how will you do that? So for that, we have this option here. Okay, stiff design area or stiff design, something like that. Let me click, yeah, draw design strips. So click on that, and here now we are going to model the design strips. Okay, so remember, when you want to draw the design strip along length, okay, we have to consider width. Remember that. Okay, I told you the strip layers. So always along length, I'll call it as A. Okay, strip layer A. Along width, I'll call it as strip layer B. If you remember the previous sessions, I hope you remember. So I'll follow the same principle. I'll not change the principles here. The ground principles remain same. But what you want to remember is when you want to draw the design strip along the length, okay, when you want to draw the design strip along the length, what we have to do, we have to consider the width portion. Okay, we have to consider the width portion. So what is the width of the footing? Let me see that. I think it is 2 point something. Yeah, 2.25. That's the width of the footing. So the width of the footing is 2.25. So where the strip will be there? Exactly at the center. So that means 2.25 divided by 2, which is 1.125 meters. Right. So select the type. Let me close this one, delete all these ones. Type of object is basically the strip area. And we are going to do it along layer A because along length it is layer A. And strip design type is basically the column strip. And then start with left, start with right, left, end with left, and end with right. All these are width of the footing divided by 2. In the earlier case, it was a square footing, so we didn't had any confusion. But here it is a rectangular footing, so we have to be very careful. So it is 2.25, okay, 2.25, which is width of the footing divided by 2. Why divided by 2? Because the strip line will always be exactly at the center. So from here, it will be there. So overall width divided by 2, that is 2.25 upon 2. Right. So 2.25 upon 2 is 1.125. So let me write the values 1.125, 1.125, and 1.125. Right. So once this is done, what we have to do, we have to draw the strip layer. So where we have to draw along the length. So move the cursor to the vertical line and make sure to see the midpoint. Once you see the midpoint, click there and then freely move the cursor to the other vertical line or other side of the vertical line, and then make sure to get the midpoint. Once you see the midpoint, then click. Once you click, you will see the pink color line. That's actually the strip area. So how to disable this command? Just right click. That's it. Now let us draw the strip along the width portion. So when you are drawing the strip along width, we have to consider the length of the footing. That is length of the footing divided by 2. What is the length of the footing? It is 2.5 meters. So 2.5 upon 2. Okay, which is 1.25 meters. So let us draw that. So here you can select the strip layer as a B, and here the column strip, and the start with left, right, everything is 1.25, 1.25, 1.25, and 1.25. Right. So once this is done, just move the cursor to the vertical line, horizontal line, and ensure the midpoint, and then move to the another horizontal line and ensure the midpoint. Once you see the midpoint, just click there so that you will see the strip layer B or strip line B, you can say. Right, you can see both the strip line. So if you want to disable the command, just right click, that's done. Okay, so that's how we can draw the strip area. Okay, you can see the pink color lines, both pink color lines. Now let's change the properties of strip. Okay, let's change the, or let us define the properties of strip. So how will you define? So let me select the object. So let it done. So now we have to change the properties of strip. So how will you select that? How will you change the properties of strip? So just select any one strip line. Okay, first I will go with strip layer A. After that I will go with strip layer B. Okay, click on that and you can see one design strip selected. Okay, one design strip selected, which is basically the horizontal one. Right, now we will change the properties of this. Okay, the rebar material, those things we have to change. So now once you select the horizontal strip and then keep the cursor on it and then right click. Once you right click, you can see whichever portion that you have selected, it will get highlighted, the blink. Okay, right. So now here we need to change couple of things. Okay, what is the first thing? The first thing is rebar material. Okay, the first thing is rebar material. So click on that and here we have to select Fe415 grade of steel. Strip layer is A, strip design type is column strip, and then design this strip, and then from preferences, or we can go with this one also. Okay, we can go with this one as well. That is specified to center of steel. Anything is fine, no problem. Okay, right, and check the from preferences. Okay, and then click OK, OK. Click OK, and then OK. So this is for strip layer A. Now similarly, we have to do it for strip layer B also. So first select that by clicking on it and then keep the cursor on the strip layer B and then right click. Right. So here also we have to change the steel. Make sure here the strip layer should be B. Okay, and then click OK. Okay, right. So we have changed the properties of the strips. Okay, we have changed the properties of the strip. So since we have made some changes, again we need to run the analysis part. So let me click on run analysis and design. So once the analysis is completed, so now what we will do is we'll check for the moments. So how to see the moments? So we have this option here, you can see show strip forces. Okay, show strip forces. So click on that one. Okay, click on this and here load combination dead load plus, so for factored load combination. Okay, for shear forces and moments, we have to look for factored load combinations and then check moment. So if you want to see the moment along strip layer A, select strip layer A and then fill diagram, show values, click apply. Now, can you see the moment, which is at the face of the column, that is 468. Okay, this is along length. Okay, this is along length. So that's fine. Now let's see the moment along width also. How will you see? So again, same, if you close this one, let me close this dialog box. Again, click on this one. Okay, show strip forces. Okay, and then load combinations. Okay, and then moment. We are looking for layer B. So select layer B and then click apply, close it. So you can see, let me not close it. You can see the moment value. Okay, which is 506.6, 506.31. That's fine. Okay, right. So now what is the leftover thing? Let me close it. Now what's the last one? The last one is we have to do the slab design. The last part is this slab design. Slab design is nothing but we will look for the reinforcement values, all those things. Okay, that's what slab design I mean. Or reinforcement design also you can say. Reinforcement design in slab, something like that. Whatever you can name it, you can name it. So I'll make it as, for understanding, I'll reinforcement slab design. Okay. So now, in order to make the reinforcement slab design, first we have to look for the slab design. So there is this option which is called as a show slab design. So you can see here, show slab design in the quick, in the main menu, in the quick access bar, this one. Okay, show slab design. Right, sorry, not this one, the next one. Let me highlight that, this one. Okay, show slab design. You can see, right. So click on show slab design, and here the design basis is basically the strip based, and then display type enveloping flexural reinforcement, and we have to check impose minimum reinforcement, and then show, we don't need to look for top bar. So let us go with only bottom bar, and then check show total area for strip or for rebar intensity, anything, whichever you look for or whichever you need, that you can check for. Okay, so check bottom rebar and then total rebar area for strip. Let us look for only for strip, and then strip layer, let it be A, and then fill diagram, show values. Okay, show values, and then let this be seen, and then click apply, close it. Or let me not close it, let me click on apply again, apply once, and you can see the reinforcement value. Can you see the reinforcement, which is 2461? But let us look at the manual calculation. So what is the reinforcement AST value? So let me look. So the AST is 3015, so which is again more or less same. So that's not a big problem. Okay, right. So now let us look the area of steel along layer B. So just check layer B and uncheck layer A, click apply, and you can see along layer B it is 2834. Okay, along layer B it is 2834. So that's how you can look for the values. So if you want to look for the other parameters such as if you want to see the number of bars, you have to give the diameter of bars, all those things. So here, let's say I want to see the number of bars. So what's the diameter of bar? So we have considered, I mean, the 12 mm diameter bars. Okay, let me give it as 12 mm, and then click apply, and you can see the number of bars here, 26, 25-12. Top it is 1-6, bottom it is 25-12. So that's how we can look for the reinforcement part. Okay, if you want, you can also change the spacing values, all these things, so which we have discussed in the last session. So you can just give it a try with the different spacing values. So how will you minimize this one, this moment diagram? So the red color one is the moment diagram. So how will you minimize this? So in order to minimize this one, so we have to give the reinforcement bar type. So let me give it as 12. Okay, so and then the spacing value, let me give it as sorry, bar is 16. So here also it is 16. Okay, and then the spacing. So if you want to minimize this movement, you have to work with the spacing value. Suppose let's say I'll give the spacing as 175 mm. So we have to minimize this moment diagram. But that can be done by changing the spacing. Let me click on apply. You can see there is no moment. That means perfectly it is fine. So there won't be any problem with the footing. If you change it to 100, again you will not see. Let us change it to 300 as the spacing. Probably now you will see. Right? Can you see? So you have to decrease the spacing in order to restrict the moment. You can see. So the change in moment. So change in this moment diagram, you can see. I'll make it to 220. Apply. You can see a small change will be there. If I give it as 200, I click apply, you can see that everything got changed. Again, very minimal. Let me give it as 150. Right, it's done. So that's how we can look for the things. So this is all about modeling, design, and analysis of isolated rectangular footing. So in the next session, what we will do is we'll look for the stepped footing design. Okay, stepped or sloped footing, anyone will look for. So that's from my end for this particular session. If you have any doubts, you can unmute and ask the doubts. Thank you.